Hello friends, so this time we are going to do the LED blinking thing. I have this Nucleo G474RE. There is already a LED blinking code running on here. So we'll be doing this, but instead of using that line by line code, we will be using the toggle function, okay? So just let us initialize a project first. Just select your board. I'm putting Nucleo G474RE. Just refer to your datasheet of your board, whatever board you have, and find out which one is connected to the inbuilt LED. So once the project is created, you can just see there are some pre-built pinouts. We don't need it, so just go to the pinout, clear pinouts. So once the pinouts are cleared, we can just define our requirement. As you can see, the LED2, that is the inbuilt LED, is connected to the PA5. So I just selected GPIO output. You can just right click on it and enter user label, that is let me put it LED. Now just go to sys and set the debug as serial wire. That's it. This much we have to do it here. Just generate the code. Okay, give the project name. And select the STM32 cube ID. Once you create it, if you create it for the first time, it will be downloading the libraries, but since I had already worked on it, it is fine. Okay, so let us just cut it and go to the IDE. Just launch the workspace where you have saved the project. Here you can see we need to add them. Just close it. Okay, go to file, open projects from the file system, select the directory. Here is the LED toggle folder, just select it and done. Finish. As you can see, there are multiple things, that is the drivers, the SRC, the helper files that are required to run it. This is the main.c, where you can see we have some pre-built code. You can define the private variables here, and yes, this is the private loop where we'll be working on. So what is this private thing? So let me just tell you in shorts. All the code must be written inside this, wherever you see the thing user, okay? Because rest all these sections are generated by the QMX. If you write something here or outside it, like here, whatever changes we make, these will be cleared once we click on the generate code of the QMX. So the generated code is nothing new or something out of the box. It is just the C code for the configuration we made using the QMX. But like the pinouts, the clock configuration, whatever changes we make, once we click the generate code, it will create a pre-built code according to it. So you can just go to the drivers inside it, STM32, whatever driver, whatever board you are using, you will see the corresponding HL driver. Inside it, SRC, you will see multiple things. Here you have all the C files provided by the HL library, like external input or flash, the GPIO that will be using, the power, the RCC, timer, everything is here. So to blink an LED we will be requiring this GPIO thing. Okay, so this is the STM32 G4XX HL GPIO.C. Here on the right side you can see the outlines. So these are the functions that have been created inside this. Okay, so you can just find out these functions here, or you can just click it, you can skip to these functions. So in the past video we did the write pin thing. You can see the syntax, it is HL GPIO write pin GPIO type def this. So this time we will be using the toggle pin. So this is its syntax. Okay, so this toggle pin takes two parameters, that is the GPIO X and the GPIO pin. So GPIO X is nothing but you can read it here. GPIO X can be from A to G, that is the port where it is connected, and GPIO pin specifies the pin to be toggled. Here we had a PA5, right? You can see the pin out configuration. We had PA5, that is port A, LED pin number 5. So accordingly we will call it. So in this way you can go through the libraries before using them. It will be much more helpful if you are going through a new thing. Then you can just copy paste the function, like you can just copy it and paste it where you are requiring it. Like in the main we will be using it. Yes, this you can just put it here. So here what we will be using, you can just type LED control space. You can see the recommendation, that is the LED GPIO port. Just enter, and here you can just cut it and type LED control space. You can see LED pin. You can just double click on it, just put a semicolon here. That's it. You can just do it easily. So while entering the port and pin, you can just enter the user defined label that we put in the MX and use it here. You can just one more thing you can do, like you can just do Control F and search the configure GPIO. Now as you can see, we have this HL GPIO write pin. In this syntax you can see the same parameters are being passed on, that is the LED GPIO port and the pin. You can just scroll and check all of them. It's quite easy. So this is the same thing that we have been using, that is the LED GPIO port and the LED pin. So let me just cut it. In the clock configuration you can see the clock is in megahertz, that is 170 megahertz system clock, and at this clock frequency if the LED will toggle, then we'll be able to see nothing. So we have to add a intentional delay here, because without a delay we cannot see the switching. So I will just write HL delay. You can just click control space for the auto completion, and I will add a delay in milliseconds. There is the 800 ms I am putting 0.8 seconds. After it you can just save it, and we'll just click on build. As you can see, it has finished building, and build finished without any errors, zero warnings. That's a good sign. So we have two things, one is the debug and another is the run. So I recommend going through the debug. Let me brief you about it. So once you click on debug, the entire code is compiled. You can just switch to the debug perspective. Here you can see the variables, live expressions, everything. Now the code is not running. As you can see, the hole in it, everything are there. It is not running. You can just step into it. It is the step into button, and another is the step over button. So step into goes for line by line execution. It is quite slow, and this is step over. It is function by function calls, like what next function is being called, it loops through it, iterates through it. So once you see everything is okay, you can just click on the resume button and it will resume running smoothly. Let me just stop it, and you can also run it normally like this. As you can see, it has successfully sent the data without the debugger thing. Okay, so let us check the hardware whether it is blinking or not. As you can see, it is perfectly working. So in the next video we will see how to control the LED based on the ADC input to it. If you found the video informative, to keep us motivated, please like and drop a subscribe so that you won't miss the further videos. Thank you.